Welcome to AI Paper Podcasts, where we dig into the latest AI research. Today we're looking at a really interesting paper called RM-R1, Reward Modeling as Reasoning. Now, for those of you keeping up with aligning large language models, reward modeling, often using RLHF, is absolutely crucial. This paper, though, it takes a different tack. It reframes reward modeling itself as a reasoning task. So instead of just getting a score or maybe some vague text their model, RM-R1, it actually generates these interpretable reasoning chains, or sometimes rubrics, to explain why it prefers one response over another.
Yeah, exactly.
And the results, pretty impressive. State-of-the-art on several benchmarks, even beating much bigger models, including proprietary ones.
It's a significant step, really, getting that transparency, understanding the why behind the reward signal.
We're going to unpack how they did it, what makes RM-R1 tick, and what it means for the field.
It does feel like a bit of a paradigm shift, doesn't it? Away from just the score, towards the actual evaluation process. For so long, we've kind of accepted the score without digging too deep into how the model arrived at it. This paper argues, and I think quite effectively, that the reasoning behind the score is maybe even more important than the score itself.
Totally agree. And the paper starts by highlighting the issues with current methods, right? You've got the scalar reward models. They often predict human preferences pretty well, but yeah, they're black boxes.
Right.
You get a number, but zero insight into why the model liked response A more than B.
Right.
Makes debugging, finding biases, or just trusting the reward really difficult, especially for complex tasks.
It's like trying to get better at writing an essay just based on the final grade. You don't know what worked, what didn't.
Exactly.
Scalar models are like that. They tell you A is better than B, but offer no useful feedback to actually improve A or B, especially their reasoning quality.
Then you have the generative reward models. They try to fix this by spitting out some text, some justification.
Yeah, they generate text, but the paper points out, quite cleverly I thought, that just because it looks like reasoning doesn't mean it is reliable reasoning. It can be pretty superficial sometimes. Sounds plausible, but doesn't hold up if you scrutinize it.
Like empty rhetoric, almost.
Kind of. The paper uses a good analogy, human grading. To grade well, you need to understand the question, have clear criteria, like a rubric, and then build a logical argument based on that rubric. A lot of current reward models, well, they stumble on one or more of those steps.
Which brings us squarely to the core idea here. Can we actually make reward modeling itself a reasoning task?
And their answer is a clear yes. That's where these reasoning reward models, REASRMS, and their main model, RM-R1, come in.
What really jumps out is how integrating these longer reasoning chains directly into the evaluation process boosts performance so much.
It's quite elegant, isn't it? Instead of trying to guess the why afterwards, RM-R1 is trained to reason through the evaluation step by step. This gives you better results and that transparency we've been missing.
Okay, so how do you actually train a model to do this? To reason about rewards? The paper outlines this two-stage pipeline for RM-R1. Stage 1 is distillation of high-quality reasoning chains.
It's like showing the model lots of examples of expert evaluations. They start with a solid instruction-tuned base model, say Qwen 2.5 instruct. Then they feed it data that doesn't just show which response is preferred, but includes detailed, step-by-step reasoning explaining why it's better.
Okay. So it learns the patterns of good evaluation.
Exactly. They train it using negative log likelihood loss on this data. It bootstraps the basic reasoning ability. Think of it like an apprenticeship learning by watching the experts.
And stage 2?
Stage 2 is reinforcement learning with verifiable rewards, or RLVR. This is where they really hone the reasoning ability. They use RL, treating the reward model itself like a policy model, and give it direct feedback based on whether its preference judgment was correct or not.
So it learns from its mistakes in judgment.
Precisely. This helps prevent overfitting to the specific reasoning chains seen during distillation and makes it better at generalizing, applying critical thinking to new situations it hasn't seen before.
It moves beyond just mimicking the examples.
Right. It develops a more robust, nuanced understanding of how to evaluate preferences through trial and error, guided by that simple correctness reward.
Okay, so that's the training. How does RM-R1 use this reasoning when it's actually evaluating LLM outputs during rollouts? They talk about this chain of rubrics or core method.
Yeah, this is pretty neat. First, there's a system prompts that tells RM-R1 to classify the task. Is it a reasoning task like math or code, or is it a chat task, more conversational?
And why does that distinction matter?
Because the evaluation strategy changes depending on the task type. For reasoning tasks, RM-R1 basically tries to solve the problem itself first.
Oh, interesting.
Yeah. Then it looks at the chatbot responses and compares them against its own solution. It checks for correctness, completeness, the quality of the reasoning steps shown, things like that.
So if it's a math problem, RM-R1 does the math, then grades the other model's attempts against its own work. That sounds much more grounded.
Definitely. But for chat tasks where there often isn't one single right answer, it does something different. It actually generates evaluation rubrics tailored specifically to that question and the conversation context.
It creates its own grading criteria on the fly.
Essentially, yes. It defines what a good response should look like for that specific situation. And crucially, it also explains why those are the right criteria for that task.
Wow. That's a big step for transparency.
It is. Then it evaluates the candidate responses against the rubric it just created.
So it's adaptive. It's not stuck with one fixed way of judging.
Exactly. It can handle the nuances of different prompts much better than a model just outputting a score. The paper also mentions they adapt this for models without system prompts, using a user prompt instead.
Let's quickly touch on the reward design for that RL stage. They mostly use a simple correctness reward, right? +1 if it picks the right winner, -1 if not.
Yep, primarily that. They tried adding a reward for formatting the reasoning nicely, but apparently it didn't make much difference to the final performance.
Huh, why not?
They suggest the base models, the instruction-tuned ones they started with, were probably already good enough at following formatting instructions from the SFT stage, so the simple correctness reward was sufficient.
Makes sense. And the RL algorithm was GRPO, Group Relative Policy Optimization.
Right, a variant of PPO. The key thing they mention is that it avoids needing a separate value function, which simplifies the RL setup quite a bit.
How does it do that?
It uses the average reward from multiple samples generated by the policy as the baseline, instead of learning a separate value predictor. Can lead to more stable training sometimes.
Clever. Okay, let's get to the juicy part. The results. They tested RM-R1 on benchmarks like reward bench, RM bench. How did it do?
The results are, frankly, quite striking. RM-R1 consistently hits state-of-the-art or very close to it among generative reward models.
Okay, good start.
But here's the kicker. It often significantly outperformed much, much larger models. We're talking open-weight giants like Llama 3.1, 405B, and even closed proprietary models like GPT-4o.
Whoa, wait. Outperformed 4.0 by how much?
In some cases, by up to 13.8% accuracy improvement. That's substantial.
That is substantial, especially considering the likely size difference. And it wasn't just accurate, it was interpretable too.
That's the other key finding. It consistently produced these coherent, understandable reasoning traces. You could actually follow its logic.
That's huge. Being able to see how it decided is invaluable for trust and debugging.
Absolutely. And the fact that their, I think it was the 14 billion parameter RM-R1 model could outperform a 27 billion parameter DeepSeek model really highlights that the reasoning approach is adding a lot of value, not just scale.
Did it generalize well? Did it work across different domains?
It seemed to, yeah. Good performance on chat, safety tasks, and complex reasoning. They also found their model distilled from DeepSeek set a new record on RM bench, especially strong in math and code, which makes sense given DeepSeek's strengths.
So different base models bring different strengths, but the RM-R1 training helps across the board.
Seems that way. And the instruct-based models were quite data efficient, needing less distillation data to get good reasoning performance compared to the DeepSeek one.
They also looked at scaling, right? With 7B, 14B, 32B models.
Yes, using Qwen 2.5 instruct as the base. And the trend was clear. The bigger the model, the bigger the performance gain from the RM-R1 training. It suggests this reasoning approach scales really well.
Promising for future larger models then.
Definitely. They also found that giving the model more thinking time at inference, letting it generate longer reasoning chains, also boosted accuracy. More compute equals better reasoning, essentially.
Makes intuitive sense. What about the ablation studies? Did they break down which parts of the training were most important?
They did, and it was quite revealing. Trying to do just RL from a cold start without the initial reasoning distillation didn't work very well.
So that distillation phase is critical.
It really seems to be. It provides that essential foundation. They also found that adding the step where the model classifies the task type reasoning or chat gave a significant boost, especially for the reasoning tasks.
Ah, so telling it what kind of problem it's looking at helps it choose the right strategy.
Exactly. And the full recipe distillation plus RL plus that query categorization that was consistently the winner across the board, the components work together synergistically.
They also compared it directly to just fine-tuning of the final answers.
Right.
Standard SFT for preference prediction.
Yes, and the reasoning-based training, whether it was the full RM-R1 or just the distillation part, consistently beat the SFT approach, even when the SFT model saw more data sometimes.
So teaching it how to think is better than just teaching it what to choose.
That's the clear message, yeah. Training the reasoning process itself pays off.
And the training dynamics. Did the distillation help stabilize the RL part?
It looked like it. The cold start RL learned gradually, but got a bit unstable towards the end. The warm start, beginning with distillation, showed much smoother, more stable, and efficient learning.
So the distillation gives it a good starting point, making the RL fine-tuning easier.
Seems that way. The case studies were also illuminating. They showed RM-R1 on a medical question, right?
Yeah, comparing it to the cold start RL model.
And RM-R1 produced this clear reasoning, created a sensible rubric focusing on accuracy, which is what you'd want for medical advice, and judged based on that.
Whereas the cold start model,
It kind of focused on more superficial things, not really getting to the core of the medical accuracy. It really highlighted how RM-R1's reasoning leads to more reliable and, well, sensible evaluations.
Okay, so summing up, RM-R1 feels like a really significant step, making reasoning the core of reward modeling, that focus on interpretability.
Absolutely. Understanding the why is just so important for improving these models, for debugging, for building trust. It's not just academic, it's practical.
And achieving state-of-the-art results while doing it, even beating bigger models, that really validates the approach and their two-stage training method.
For everyone listening, especially AI researchers, ML engineers, this offers some really valuable techniques for building better reward systems. More effective and, crucially, more transparent.
Plus, they open source the models and code, which is fantastic. Gives people a chance to build on this directly.
Definitely check that out. And the findings on scaling, the importance of that high-quality distillation data, those are key practical takeaways if you're thinking about training your own reward models.
They also pointed towards future work, like automatic rubric generation. That sounds exciting.
Yeah, lots of interesting avenues still to explore. How could these reasoning reward models change how you approach alignment or model evaluation? Something to think about.
Definitely dive into the paper if this sparked your interest. Links are in the description, as always. Understanding these reward modeling advances is pretty critical as we try to build AI that's genuinely helpful and aligned. Thanks for tuning into AI Paper Podcasts.